I'm going to start with question number 2. So let's look here at question number 2. Okay, now on question number 2, we need to make sure that we're careful with the wording. So this is even on these integers. Okay, so what do we know about even? Is the gap 1 or is the gap 2? The gap is going to be 2, right? This is 1, 5. Okay, someone asked about 1, 5, right? Question number 2. So the gap is going to be 2, isn't it? Because I highlighted the key word here, integers. And we're looking at the sum of what? Sum of the squares. So what would that look like as an equation here? Okay, the sum of the squares of 2 consecutive even integers. So that means my first number is x. My second number is going to be x plus 2. Now, what do we know? We know that the first number squared plus the second number squared has to equal that 52. Is everyone okay with that setup? Because we're going to have to square them. Now let's write them out. And so that's going to be 1 squared, so that's going to be x squared. Your second number squared, well, that is x plus 2, quantity squared. And that equals now your 52. I'm going to do one more step, and then you can finish it. So let's go ahead and work with this. X plus 2 times x plus 2, that's got to be FOILed out, and that's x squared plus 2x plus 2x plus 4, which is then x squared plus 4x plus 4. Okay, so this is what we've got. I'm going to let you finish it from here. Bless you. Okay, so this is what you've got left. You can combine like terms, and you're going to set it equal to 0. You're going to get 2 solutions, and you're going to get 2 pairs of numbers. A positive pair and a negative pair. So you can finish this by setting it equal to 0 and factoring. You could probably factor a 2 out as well. So add the x squareds together, move the 52 over, probably divide out a 2 everywhere, factor it, get your 2 solutions. You're going to get 2 sets, a positive set and a negative set. Okay. But I think you could finish it from there because those will go together. You should have no problem finishing it from here. Okay. Question 7. Question 7, and this again is out of 1.5. So question 7. A rock falls from a tower that is 117.6 meters high. As it is falling, its height is given by this formula, where t is in seconds. How many seconds will it take for the rock to hit the ground? And what are we looking for here? Rock to hit the ground, that means h is going to be what? 0. So let's write up our formula. Six minus that 4.9 t squared. We're going to use h equals 0. So that gives you this. Okay, now, how would we solve this? A lot of times students struggle with what method to use. How would we solve this? Are we going to use 0 factor, do you think? The quadratic formula or the square root property? Which one? How would you solve this equation? Well, what do you think you would use? Square root property. Very good. How would you do it then? Yep, move that 117.6 over. And that gives you a minus 4.9 t squared equals a minus 117.6, right? And I'm going to go ahead and finish this one. Just to refresh your memory on how to use the square root property. Yep, okay. Divide out by that minus 4.9. And now we've got t squared equals, use our calculator here, 17.6 divided by 4.9. That comes out as a 24. And now we know what to do. Use the square root property. Add on your plus or minus. Okay, now, what does it say? It says, how many seconds will it take the rock to hit the ground? So, does it say anything about rounding? No. 24 is not a perfect square. So we're going to use our calculator, and we're going to get it to the nearest second. Nearest second will be close enough. So we're going to take the square root of that 24. And that comes out to then give you plus or minus, yep, 4 point, yep, if you round 8, 9, goes on forever. So, or about 5 seconds. So it should take about 5 seconds. You don't have to worry about the minus case. Why not? Okay, can't have a negative time, can you? Right? So it should take about 5 seconds for this rock to hit the ground. Now we have the plus or minus here. When we write our answer, though, we don't put the minus because it's time, and time cannot be negative. And I just got that to the nearest second, close enough. So it should take about 5 seconds for that to reach the ground. Okay? It doesn't say anything about rounding, so I'm just going to go to the nearest second. We also asked about question 8. And 7 and 8 are very similar to each other. A little bit different, though. Okay. Question 8. Pretty much the same, but we want it to the nearest what? 10th. And we want it to reach 133 feet. So this is what we've got. We've got S equals 16 t squared plus 32t, and we're going to use S equaling 133. And this one is probably going to require us to use the quadratic formula. I'm going to get you started. You're going to have to finish it. So I'll get you about halfway through using the quadratic formula. I usually don't work these out completely, but I get about half of it done. So I cannot use zero factor, I don't think, and it says round to the nearest tenth, so that pretty much tells me that it's the quadratic formula. Why can I not use the square root property? Because you have t and t squared, right? So that means you cannot use the square root property. You have to use either zero factor or quadratic. It says round, so that means it's probably going to be quadratic. So we're going to begin by moving that 133 over. It's not going to factor, right? So we're going to use the quadratic. Can I divide anything out? I don't think so. 133 doesn't have a 2 in it, does it? Yep, it's not. That's an odd number. I don't think anything will factor out of there. Because 16 just breaks down to 4 and 4, and 2 and 2. So this doesn't have a 2, so nothing will factor out. It's set to 0. We're going to use our quadratic formula. So my A is 16, B is 32, C is minus 133. Okay? apply our quadratic formula, and then I'll let you finish it. So I'm going to put it in the quadratic formula. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to plug the values in, and you can finish it. So that gives me a minus 32 plus or minus square root now of 32 squared minus 4 times 16 times a minus 133 all over 2 times 16. I think you can finish it from there. So you should know what to do. We covered these way back in 1-4. So you've got it set up for the quadratic formula. I did about half of the work for you. You'll do your discriminant, put it all back together, and how far do we round at the end? Round nearest tenth, so that's 1 decimal place. I would take it out probably 3 until the end. Is everyone okay with how to use the quadratic formula? So I just don't like to work these out completely unless we really, really need to, because I want to leave something for you to do. Question 10. Okay, question 10. We've got 2 cars. Okay, one is going north, one is going east. When the car traveling north had gone 12 miles, the distance between the cars was 4 miles more than the distance traveled by the car heading east. How far had the east car traveled? So what we have is we've got 2 cars. We've got one heading north and one heading east. And so what do we know about these cars? When the car traveling north had gone 12 miles, so that means this is 12 here. The distance between the cars, that's this piece here. That's the distance between, is this dotted line. And the distance between the cars was 4 miles more than the distance by the car traveling east. Well, we don't know the car traveling east, so we're going to use an x. And we know the distance is 4 more, so that is x plus 4. Is everyone kind of okay with how we set that up? So 12 miles north, east car we don't know. Diagonal is going to be x plus 4. Now, what are we going to use here? It's a triangle, so that means we have to apply the Pythagorean Theorem, isn't it? So that's what we're going to apply. Okay, and let's go ahead and set it up. What's the most important part? Make sure that your diagonal is the C. The A and the B really don't matter. It's the C that's important. Make sure your C is that diagonal. So we know that A squared plus B squared equals C squared. So rewriting, then, we've got 12 squared plus x squared equals x plus 4, quantity squared. Okay, I'm going to do one more step here, and then I'll leave the rest of it for you to finish out. What am I going to do on the right-hand side? What am I going to have to do with this? That's going to have to be FOILed out, isn't it? So that's going to have to be done on the side separately. So let's go ahead and do that on the side here. So over to the side, we've got x plus 4 and x plus 4. So those are going to get multiplied together, FOILed out, and that's x squared 4x and another 4x makes it 8x. And 4 and 4 leaves you then with a 16. 12 squared is 144. And I think you can finish it from here. Now, I will tell you that this one is going to be linear, which means at the end you're only going to get one answer. Why? Because what's going to happen with the x squareds here? This one and this one, they're going to do what? They're going to cancel, right? So you're not going to have to factor it. You can directly solve it because it's linear. So the x squareds can cancel. Move the 16 over and divide by 8. Because those x squareds will cancel it. Is everyone okay with that? You should be able to finish it from there. I know the setup is where students always struggle the most. I think that now finishes up the questions out of 1-5. Now we'll look at some questions out of 1-6. And 1-6, there's a variety of different questions. Different types. We're going to begin with question 4. Okay, so we're going to begin with question 4 now. Yep, this is 1-6. Yep, we're going to be looking at question 4. So what's the first thing that we need to do? First off, everything has to be factored. Now, it should be relatively easy to factor because it's all trinomials or difference of squares. So let's go ahead and try to factor it. That way we can get our domains. X squared minus 4. X squared minus 4, that's a difference of squares, isn't it? So it's a difference of squares, so x plus 2 and x minus 2 is that piece. What about this one? First times the last is a 6. What two numbers give you the 5? Multiply together to give you 6. Yep, 3 and 2. Okay, so that's going to be that piece, 3 and 2. So now we have that minus 3 on the top. And then we have a x plus 3, x plus 2 down below. So here's that piece. Equals, what about the other one? Minus 6. We want it to be a 1. What two numbers are going to work here? Yep, watch your signs. Looks like it's going to be a positive 3 and a minus 2, doesn't it? The sign in the middle is positive. So that's going to be now a 3 over x plus 3, x minus 2. So is everyone okay with how everything got factored down? Right, they're fairly easy to factor. They're all either simple trinomials or the first one is a difference of squares. Now, what do we need to do after that? Before we clear our fractions, we need to see what numbers are not in the domain. That way at the end we can check our answers. So what numbers are not going to be in the domain? Let's talk about these. Okay? Okay, let's go through each one. Okay, what number is going to make this not work? Minus 2 and positive 2, right? So minus 2 plus 2 is 0. We don't want that. 2 minus 2 is 0. We don't want that. Over here, we need a minus 3. Because minus 3 plus 3 is going to give you what? 0. Can't have that. Okay. this one's already taken care of with the minus 2. The x plus 3 is taken care of with that minus 3 there. And the minus 2 is also taken care of with the 2. So these are the numbers that are not in the domain. Minus 2, positive 2, and 2. Now, I'm going to work out about half of this question, and you can finish it from there. We've gotten about a quarter of it done. We need to finish it. So I'm going to work some more of it out. How would we clear out our fractions? Let's talk about that process. So we need to clear out our fractions. So let's rewrite it again so we can see what we've got and what we need to multiply by. So we have to look at it as a whole. So what are we going to need? Well, let's see. Okay, so we want to multiply here. So to clear this out, I'm going to need an x plus 2, x minus 2, right? And then I also need x plus 3. That's going to take care of everything. Okay, now we take our time and see what happens. Okay, so what's going to happen on our first one? The x plus 2 and the x minus 2, those can cancel directly, can't they? So what's going to be left over? Yep, 5, right, from there on the numerator, times the x plus 3. And we've got a minus 3, and what cancels out here? Those two, and those. So what's left over? Yep, negative 3 times an x minus 2. So that's that piece. And then we go to the right-hand side. Minus 2's and the 3's cancel. And so that now leaves you with a 3 times what? X plus 2. And I think you can finish it from here. So I did about half of it, actually probably 3/4 of it. But what are you going to do to finish it? Distribute the 5 through, distribute the minus 3 through, distribute the 3 through, solve it. This is linear, so you're not going to have to factor. Okay, it's a direct solve. Now, what numbers can you not have as a solution? Right, so if it's any of these, what does it have? No solution. Right, cross it out. So hopefully that helps you set that one up and finish that one. 9 is next. So there's your equation, and you should be able to finish it. It shouldn't take that long at all to finish it out. Question 9. Okay, question 9, we're looking at accountants putting together a tax return. Now, this is a work question, so whenever we do a work question, we have to write these as fractions. So an experienced accountant can prepare a tax return in 8 hours, and the novice can do it in 14. How long will it take them if they work together? So let's look at each one of these and see what we've got. We've got a novice and an experienced person. So the novice person and the experienced person, we'll start with the experienced person first. With the experienced person, it takes him 8 hours to do that return. So how much is done in 1 hour? Okay, someone said it. 1/8, right? Time is unknown, so we use an x. The novice account. Right, so for the novice account, it takes 14 hours, right? So that means we use 1/14. and the time is x. Now, what are we doing here? Adding or subtracting? Adding, because they're working together. So what does our equation look like? Yep, x plus 1 over 14x, and that equals what? 1. Always 1. Now, how can you finish this? You're going to have to multiply everything by what? I think, yep, 56. You clear it from there. Okay, so you can finish it. Is everyone okay with those? These are a question you might see on your exam. That's a good question. When I make up your exam, I'll probably put something like one of these on there. Pretty straightforward, pretty easy. Make them fractions, set them equal to 1. Okay. 2 more. So 13 and 14 are next here. So 13. Let's see how we would approach 13. Okay, so what's the general idea here? Okay, this has 3 terms. Right, now, what's our highest power? 4. So that means at the end, we're probably going to end up with, at most, 4 solutions. So we're going to have to set this to 0, factor it, and then use the square root property. So let's move it around. Now make sure we get it in the correct order, because it's easy to get it mixed up. And that leaves me then with an x to the 4th minus 141x squared plus your 2,000 equals 0. I'm going to go ahead and factor this. So 1 times the 2,000 is your 2,000. Okay, now, how do I find the numbers? Well, it's 2,000, so I've got to think about what I can use. It ends in a double zero, actually triple zero, so it's going to have something in it with a 0. Let's start off with, well, 10 definitely is not going to work. How about we try, we'll try 20. Let's try 20 first. See how close we are. Okay, that's 100. Okay, so 20 and 100 is 120. What do we need? 141, right? So let's try 15 because it's too small, so we need to decrease the number. So let's try that to 15. So we'll take our 2,000 again, divide that by 15. And it doesn't go in there evenly, does it? But it's pretty close. Okay, let's try let's see, we got the 2,000. Let's see, how about we try a 16? Does 16 work? It's close to it. 16 and 125. That works, doesn't it? Okay, so what are my two numbers? Both the same, negative. So we need a minus 125 and a minus 16. How did I find those two numbers? That sometimes is the harder part, right? What did I do? So I tried 20 at the beginning. Okay, and what did 20 give me? 120. We needed 141. So I used 20, and it gave me a number that was too small. So then, or too small here, so I have to go down. So I knew that it's going to be less than what? Less than 20. So I tried 15. That was 133, close to it. Okay, we needed this 144, so I need to go up a bit. So I went up to the next number, which was 16, and it worked. It's just a matter of trial and error until you find it. Now, once you've gotten that, let's do a couple more steps. So that is now going to be, when I break it down, not x and x anymore. It's x squared and x what? Squared. Minus 125 and a minus 16. Okay, now what do we have to solve? We've got to solve x squared minus 125 equals 0. And the other one is x squared minus 16 equals 0. And I think you can finish it from here. Right? So you're going to have to use the square root property on each of those. Move that 125 over, take your square root. Move the 16 over and take your square root. They're both going to be real numbers. And you're going to end up with 4 solutions. Why? Because of the plus or minus. So is everyone okay with how to do that? So use the square root property, move things around. So that takes care now of question 13. Do you have a question? Yep. Yep, that's right. 5 squared root of 5. Yep, exactly right.
I know that it's for
Yes, that's right. Yep, that's right too. Yep, 5 squared root of 5 is correct. Yep, very good work.
If I make it like this,
Okay. It's not plus or minus 25 because it's going to be 5 squared root of 5.
Yeah.
Right? Yes, you can leave it as a plus or minus. Yep, that's fine too. But it's not that 25 though, it's 5 squared root of 5. Yep. Question 4 out of 1-5? Yeah. Sure, yep, we can go back and look at that one too. Yep, 1-5, we'll look at question 4 next. Okay, so let's go ahead and do 14, then we'll go back and do question 4 out of 1-5. So is everyone okay with how to finish that? And you can write it with the plus or minus, that's okay. So if you want to use the plus or minus, that's all right too. 14 is next. Okay, now, there are 2 ways of looking at this one. It's set to 0. It's got the 3 terms. Now, we could try the first times the last. But if I did that, okay, if I take that 25 and I multiplied it by the 36, look at what you're going to have to deal with. You're going to have to deal with 900. And then because of that 25, you're going to have to do by grouping. Now, there is an easier way. When I look at this question, and I look at the beginning and the end, and I look at a 25 and I look at a 36, those are special because they're both perfect what? Perfect squares, right? Because 5 squared is what? 25, and 6 squared is 36. So I can actually come up with my answer pretty quickly because this would now factor into it's a perfect square trinomial. Okay, 25 is a perfect square of 5, so that's 5x squared. We're going to bring down the negative. And 36 was a perfect square of now what? 6. So always check for perfect squares. If your ends are perfect squares, it's a perfect square trinomial. That's going to save you a lot of time. Now, how do I finish it? What would you use? What technique? How do I get rid of the square? Okay, square root. And the square root of 0 isn't signed at all, so it still stays at 0. This one's only going to give me 2. Because this is a perfect square trinomial because you have, the 4 gives you at most. Okay, so you may not get up to 4. It may be less. This one's only going to have 2 because this was a perfect square trinomial, which means you got a double solution here. And then when you got rid of it, it gives you this. So this is only going to give you 2 solutions total because of the 0. Because this was a perfect square trinomial. So you're going to end up with 2, right?
But you get 4 though, right?
Yeah, but you'll get If you got the 4, there'd be 2 of them that were repeated twice. Because this, okay, this is the same thing as that. Right? That's the same thing as that, isn't it? And these are the same. So all you really have to solve is what? One of them. And so that's going to give you then 2 solutions because of the square. Does that make sense now? So you actually do have 4, but 2 of them are duplicates. So that's why when you finish this one out, you're only going to get 2. You actually get 4, but 2 of them are duplicated. So yeah, it will, because you'll just solve this. How would you finish this out? Right, yep. If I was going to finish this out, I would go ahead and add 6. Okay? And then I would divide by 5. Yep. And then I would go ahead and take the square root, add your plus or minus in, and that gives you then this. A lot of times, though, they'll also get rid of the denominator that has the square root in it. So you could leave it like this, or you can rationalize it and multiply it by the square root of 5 or the square root of 5, which would then give you, to rationalize it, plus or minus the square root of 30 over 5. But I would take either one. I would take either this or that. Same thing. You may or may not remember how to rationalize. If you don't rationalize and leave it like that, that's okay for this class. If you wanted to do it the formal way, you would multiply it by the square root of 5 with the square root of 5, and that would actually rationalize it. But I would take either one. They're the same. Okay. Prefer this one, but if you get to that step, that's enough for this course. If you take a calculus course, you have to rationalize. But if you can at least get to this step, that's enough. Okay, but that's the answer the textbook would have. And that's why you're going to get 2, because of plus or minus. And these are the same. Let's now go back and look at 1.5, question number 4. I believe someone asked about that. So 1.5, question number 4. So the height of a box is 5 inches. Its length is 5 inches more than its width. And I want to find the length if the volume is 120. So what do we have here? We've got a box. So it's a 3-dimensional object. So I'm going to draw the box here. So this is what we've got for our box here. Now, what do we know about this box? Okay, we know this box has a height of 5. So that's going to go here. Its length is 5 inches more than its width. So we don't know the width. So that's x. The length is 5 inches more. So that's x plus 5. And we know the volume. And by the way, this is question 4 at 1.5. The volume, length times width times the height. And so we multiply all these together. That is going to equal a volume of 120. So let's think about what we've got here. Make sure we understand what we're doing. Okay, we have our figure here. This is a box, the height of 5, width is unknown, length is 5 more. So that's x plus 5. It equals 120. Now, I am going to show you something you can do to save some time. What do you notice about both sides? Both sides are divisible by what number? 5. So let's go ahead and divide it by 5. And that's going to save you a bit of time here. It's going to make it an easier question to deal with because the numbers are smaller. Anytime you get the number smaller, that's going to make it helpful. So we'll take that 120, we'll divide it by 5, and that's going to now give you a 24. And you can finish it from here. How would you finish it? Yep, you would distribute that x through. Now, it doesn't say anything about rounding, so I imagine it's probably going to be 0 factor. If it doesn't say anything about how to round, it's normally going to be a 0 factor. So you distribute that x through, set it to 0, try to factor it first. If it doesn't factor, then use the quadratic. But it's usually a lot easier to factor than use the quadratic. And it should factor out nicely. So now let's go ahead and start the next section. And again, if you don't have all your homework finished today, you can turn it in next class period. If you've got it finished, I'll take it at the end of class period today. But otherwise, we will pick it up next week. Or not next week, on Thursday. So let's now go ahead and start section 1.7. And it's going to be an easier section. I think you'll find 1.7 to be quite a bit easier. 1.7 and 1.8 are a lot easier to work through. And 1.7, we're going to look at inequalities. Okay, so 1.7, we're going to look at inequalities. And before I forget to, let me pass out the homework packet, if that's what I was forgetting to do. Knew I was forgetting to do something. Let me give you the new homework packet before I forget. Here's the new homework packet. So this is our new homework packet. We may not finish all of 1.7 today, but we'll finish most of it. The other class this morning didn't because they had a lot of questions as well, but we'll get through most of 1.7. So we're going to look now at 1.7, and we're going to talk about inequalities. And with these inequalities, we're going to have to be graphing them. And when we graph them, greater than or equal to, less than or equal to, those, we're going to use square brackets. Strictly less than, strictly greater than, we use parentheses. A negative or positive infinity, you use parentheses as well. Now, one thing we have to remember about inequalities is when you divide by a negative, does anyone remember what's going to happen to my symbol? When you divide by a negative, that flips your inequality symbol. So let's remember that. So let's note that when dividing by a negative, flip the inequality sign. So you're going to want to flip that inequality. We're going to begin by looking at linear inequalities, and then we'll talk about quadratic, and we'll do the rational ones on Thursday. So the linear ones are pretty simple to solve. When we get our answer, we're going to have to put it on a number line. So let's look at some of these. We'll look at single inequalities, and we'll also look at some double inequalities, so 3-part. So let's start off with a fairly simple one. Bless you. Okay, so let's look at this one, and that's a 9 there. make sure you see that's a 9. So this is what I want you to solve, and I made this one pretty easy to deal with. First thing is distribute your negative 9 through, or sorry, negative 3 through. And that leaves you with a negative 3x. Negative and negative makes it a positive 27. Inequality symbol stays the same so far. And we have a 4x minus 5 on the right-hand side. Now we move things around, so I'm going to move that 4x over. And I'm also going to move that 27 over. 4 and 3 makes it a 7x, and it's negative, isn't it? And then we've got 27 and 5. That should make it a, 32, isn't it? I always like to double check things, so I don't make a mistake. Yep, that's 32. And it's negative as well. When I made up this question, I picked it out specifically to make sure we understand that when we divide by this negative 7, what happens to my symbol here? Yep, so make sure you're careful with that, and that's going to flip that around. Okay, so flip your inequality symbol. Negative and negative makes it a positive. Okay, is everyone all right with that so far? So move things around, got it solved. Now, how do we graph these? A lot of times, students struggle with how we graph these. So we go to our number line, and we put our 32 over 7 here. How do I graph it? Which way do I know to shade? Look at which way it points. Notice it points, right? It points to the right. So that's where we're going to shade. We're going to be shading over here. And are we going to use a bracket or parentheses, do you think? Which one? Yeah, parentheses, right? Why? Because remember, strictly less than, strictly greater than, those get parentheses. This one gets parentheses. And where does it go to? Positive infinity. So what would my answer look like now in interval notation? We read it from left to right, so it's going to be a 32 over 7 with parentheses, comma, positive infinity with parentheses. Okay. Let's do another one. Let's do a 3-part inequality. These you should kind of know how to already do. You shouldn't struggle too much with these. But let's now look at a 3-part. We'll do 2 more of these, and then we'll look at quadratics. So if I gave you this one, how would you go about solving this one? Well, we have 2 inequality symbols. And we need to, in this case, keep the x trapped in the middle. So I would move the 5 over with subtraction. And 8, 5 makes it a minus 13 there. We still have a 4x in the middle. And 2 minus 5 makes it a minus 3, doesn't it? How are we going to finish it? Divide by 4. Do we switch the symbols around? Yes or no? No. Why not? We divided by a positive 4, didn't we? So these are going to stay the same. Put them on a number line. They are in the correct order. And so we have a minus 13 over 4. We have a minus 3 over 4. Okay, what gets what? That one gets brackets. That one gets parentheses. So the minus 13 over 4, it gets brackets. The minus 3/4, that gets parentheses. And my answer is in between. So what does my answer look like in interval notation? Well, it looks like square bracket, 13 over 4, comma, 3 over 4 with parentheses. let's do one more of these, and then we'll move on to what are called quadratic inequalities. Sorry. Yep, I missed a sign, didn't I? Yep, that should be a minus there, shouldn't it? Yep, sorry about that. Very good work. Yep, that should be a minus 3/4 there. If I make a mistake, be sure and tell me. Thank you. Should be a minus there. Okay, so let's try another one of these. Now, this one's going to make us change the signs. So I need to clear out my fractions. So what fraction do we have in the denominator? Okay, we have a -3. So I'm going to multiply everything by a -3. That's going to clear them all out. And what happens when I multiply by a negative to my signs? Same thing as dividing. When you multiply or you divide by a negative, normally we divide, but that switches your signs, doesn't it? So let's go ahead and see what we've got. Negative and negative, that makes it a positive 30. Switch the inequality symbol. Those 3's here, they directly cancel. So that leaves you with a 5x plus 2. Switch the inequality symbol. And 2 times a -3, well, that's a -6. Those just canceled out right there in the middle. Now we know what to do. Yep, so now we go ahead and take away the 2. Now we've got a 28, we've got a 5x in the middle, and we've got a -8. Divide by our 5. And now we've got this. Now we have to be careful because the order is not right. Because the order on the number line is mixed up as well. We divided by a negative, which meant we switched the inequality symbols. That also means that we changed the order on the number line. So make sure the negative numbers are on the left, positives are on the right. So we would need a -8/5 here on the left. And over here is going to be the 28/5, right? Make sure they get switched around. And what do we have for each one? For the 28/5, it gets square brackets. The -8/5, well, it gets parentheses, and my answer is right here in the middle. And so now in interval notation, it looks like -8/5 with parentheses, comma, 28/5 with square brackets. And that's your final answer. Is everyone okay with that? Now, these, we did not have to check our answers. On the quadratics, which we're going to look at next, we're going to have to check our answers. We're going to have to put them on a number line, and we're going to have to check each piece to see which regions are true and which regions are false. So let's do several of these. How about we use a 9 there? So this is a quadratic inequality. So this is going to be a quadratic inequality. We need to solve this like we would any equality. So that means we're going to have to factor. And these are simple to factor. They're not difficult at all. I always like to box my original so I don't lose it. So I put a box around it just so I don't lose it. And I'm going to rewrite this with an equal sign. So I'm going to replace that inequality with an equal sign. And this way I can solve it. So I move the 9 over. And now we've got x squared plus 8x minus 9 equals 0. And once we're at this step, now we should have no trouble factoring. And what's that going to factor into? Yep, so positive in the middle. So we need an x plus 9, it looks like, and an x minus 1, isn't it? Okay. And x plus 9 equals 0, so x equals a negative 9. And x minus 1 equals 0, so x equals 1. How is this one going to be different? Well, this is an inequality. If it was an equal sign, we would be done. All right, but this one is not. This is an inequality. So what we're going to do is we're going to put these on our number line, and then we're going to make regions, and we're going to check a number in each region to see if it's true or if it's false. So put these on the number line in the correct order, and that means we've got negative 9 and positive 1. And we've got 3 regions. These are called critical points, and they're where the signs switch back and forth between true and false. We need to check numbers in each region. So region number 1, we want numbers that are less than negative 9. So let's pick a number smaller. How about negative 10? That's definitely smaller. What about between minus 9 and 1? Well, any number we can use that's in there. How about 0? 0's in there. And we need a number bigger than 1. How about 2? So these are the numbers that we're going to be using. Now we're going to use them in our original inequality. X squared plus 8x is less than 9. And so we're going to check each one, and we're going to see if it's true or if it's false. Okay, we're going to plug it in, see if it's true or false. So let's check the negative 10. Okay, 10 squared is 100. 8 times negative 10 is minus 80. Add those together and we get a 20. Is that true or false? False. Okay, so that means this part is false. Now we do the next one. And normally they will switch signs, but not always. So you need to check all 3. If you just assume they switch, you'll make a mistake. So let's pick the 0. We're going to pick 0. And we've got 0 squared plus 8 times 0 is less than 9. That is 0. And is that true or false now? True. So this one was false. This one was true. And the last one we're going to use is 2. And we know 2 squared is 4. And 2 times 8 is 16. And that gives me a 20. And again, is 20 less than 9? Is that true or is that false? That's false again. So, where's our answer? Right in the middle. Brackets or parentheses? Yep, parentheses, because our original had the parentheses. And so what's our answer? Well, our answer is now minus 9 to 1. So you shade where it's true, and that becomes your answer. Now, most of the time, but not always, they will switch back and forth. So it'll go false, true, false, or true, false, true, but not always. Now let's extend this out to more critical points. I'm going to give you one that has already been factored. This one's going to have 3 critical points. And just so you can see, okay, there's my answer right there. So that's my answer from the last one, minus 9 to 1. So let's try and solve this one. This one has already been factored, but you're going to get more points to check. So I want you to work with this one. Now, you do not have to FOIL it all out and multiply it together because it has already been factored, right? It's set to 0. It has already been factored. So that means we set each one to 0, and we're going to end up now with 3 different critical points, right? And they're going to go on the number line, and you're going to actually have to check 4 regions because you always have one more region than you have numbers. So let's go ahead now and get our critical points. This has already been factored. Right, that's my original. I like to box it so I don't lose it because it's easy to lose track of that. And what are we going to use? We're going to use negative 5. We're going to use positive 3. And we're going to use negative 9. So those are my 3 points. Minus 5, positive 3, and negative 9. Put them on the number line. Make sure they're in the correct order. So minus 9 is the smallest, so it's furthest on the left. And then we have a minus 5, and then we have a positive 3. I need a number smaller than negative 9, so negative 10. Between minus 9 and minus 5, you can use whatever you'd like. We can use a minus 6. That'll work. Between minus 5 and 3, make it easy. Use 0. And bigger than 3, how about 4? So now we're going to go ahead and finish this out. And so we're going to check them back in the original. So x plus 5, x minus 3, x plus 9 is less than or equal to 0. So let's start with a negative 10. Okay, we've got to check each one. You can't skip steps. You can't just assume that they switch back and forth. You have to check each one. So that's minus 10 plus 5, minus 10 minus 3, minus 10 plus 9. Minus 10 plus 5, that's a minus 5. Minus 10 minus 3, that's a minus 13. Minus 10 plus 9, that's a minus 1. Multiply those together. 3 negatives stays negative. And 5 times the 13, well, that is a 65. So that's a negative 65. Is that true or is that false? That would be true. So that's true. Now we do the next piece. Negative 6. So minus 6 plus 5. Minus 6 minus 3. And minus 6 plus 9. Okay, minus 6 plus 5, that's minus 1. Minus 9 for the next piece. Positive 3. Multiplying those together, 2 negatives makes it positive. 9 times 3 is a 27. True or false now? False. Okay, the next one, 0. And we're going to check 0. So if I plug in the 0, I have 0 plus 5, 0 minus 3, 0 plus 9. So that's 5 times a minus 3 times 9 makes it negative. And that's 15 times 9, which is then a minus 135. And that would make that now true, isn't it? Okay, so now we know this piece is true. And the last one should be false, but we're going to check. Always check. Don't ever just assume that it's false. Usually they will switch signs, but not always. So check the 4. And that's going to be 4 plus 5, 4 minus 3, and 4 plus 9. So that's 9, 1, and 13. And 9 times your 13 is 117. And is that true or is that false? False again, which we thought it should be, but we have to check. Don't ever just assume. Don't ever just assume that it's false. Okay, so that makes that piece now false here. Where do we shade? The true parts, so it's here, and it's here. That's negative infinity. Brackets or parentheses? It looks like square brackets, doesn't it? And so how do I express my answer? Okay, we start from left to right. So how do we express our answer? We start with negative infinity. It goes to negative 9 with the square bracket. Then we use a U for union. And we have a minus 5. And it goes to a positive 3. So that's what we've got there. Now, these have had solutions. Let's look at something now that does not have a solution. And then we'll look at something that has an infinite number of solutions. Well, let's not use 3 again. Let's use a 9. Okay, yep, we'll make it a perfect square. We'll make it a 9 there. Okay, so let's say I give you this. This is a 9 here. Sorry about that. It's a 9. Okay, this one is not going to give us a solution. And let's see why not. So if I was going to solve this, what property would I use? We're not going to use zero factor. We're going to use something else. Does anyone know what property that I would use here? Square root property. Okay? And let's remember, too, whenever you take the square root of a negative number, what happens to that negative number? It becomes an I at the end. So if I rewrite this, I get this. I get that equaling a negative 9. And I'm going to go ahead and take my square root, plus or minus, and now we have the problem. Because what's the problem now? Now I have x minus 3 equals plus or minus 3 what? I. Okay, now why is this going to be a problem when we go to graph these? Well, when we put these on the number line, can we put imaginary numbers, i's, can those go on the number line? Yes or no? No. Okay, so that means we have no complex numbers, no imaginary parts on the number line. So then we have to check a number. So let's recap what I just said here. We solved it out and we got the 3i. That's imaginary. That's a complex number. So imaginary numbers are not on the number line. So once it's not on the number line, you need to check a number. So check any number. I'll just usually have you check 1. And I want you to see what the sign will be. So if it's an imaginary number, I can't put them on a number line. It's either going to be true or it's going to be false, because it never changes signs. So I pick any number that I want to check. And I'm going to make it easy. You could have picked 0. Okay, I picked 1. So let's see what happens when I pick 1. I'm going to use x equals 1. 1 minus 3, quantity squared, is less than or equal to that negative 9. 1 minus 3, well, that makes it a minus 2. But what happens when you square a negative number? When you square a negative, it becomes a positive 4. Now, this is true. It's always going to be true. Why is it always going to be true? Because whenever you square a negative, it comes out to be what? Positive. So this can never, ever work. Because you're saying this, no matter what it is, can never be negative, right? It's always negative. It's not. This comes out to be now. Oh, did I write it wrong? Sorry. Why did I write true? It should be false. I was thinking wrong. It should be false. My mistake. Sorry about that. Should be false. Okay, sorry about that. So this is always going to be false, right? Because when you square a negative, it becomes a what? Positive. So this is false, because that would. And so if it's false, what do you think your solutions will be? No solution. Okay, now whenever you get an imaginary number, check 1 or any number that you want and see if it's true or if it's false. If I would have flipped the sign around, it would be the opposite. It would be true. And it would be everything. We've got enough time to look at one more. And this one's going to come out to be true everywhere. But let's pick one that works. So this one's going to give us an infinite set of numbers. And you can't graph this because there's nothing on the number line. But let's solve this one. So I'm going to give you this to solve. Now the last one, it had no solution, and it was false. We had imaginary numbers. We couldn't even graph them. We plugged in a number to check to see what happened, and it came out to be false, so we had no solution. This one is going to give us one solution. How would you solve this equation? What property would you use? Okay, square property. So this is our original. I like to highlight the original so I don't lose it. And I'm going to apply the square root property. And when I take my square root property, I usually have to put on a plus or minus, right? But 0 doesn't have a sign, because the square root of 0 is what? 0. So I don't have to worry about the plus or minus, because 0 doesn't have a sign. And so that gives me then x plus 8 equals 0. I'm going to move my 8 over. And now we've got x equals a negative 8. We're going to put this on our number line. And I'm going to go ahead and pass out the sign-in sheet before I forget. So I can find that real quick. And we're going to finish this one out. This will be our last question here. Find the sign-in sheet. It should be around here somewhere. Oh, here it is. Okay, so we are going to have to put this on a number line, and we still have to check. We have to check both sides of this. So I need a number smaller than negative 8. How about negative 9? And a number bigger than negative 8. How about 0? You can use any numbers that you want, as long as one is smaller and one is larger. And we're going to check and we're going to see what happens. So we're going to check the negative 9. And we've got minus 9 plus 8, quantity squared, is greater than or equal to 0. And that gives me a minus 1 squared. But what happens when you square negative 1? Positive. And is 1 greater than or equal to 0? Yes. So that would make that then true. Okay, so this half is true. Check the other side. Check 0. 0 plus 8 squared is greater than or equal to 0. So that's 8 squared. And 8 squared is what? 64. And is 64 bigger than 0? Yes. So that is also true. Now, both sides are true, so what does that cover? That covers the entire line. So then what would your solution be? Yep. Your answer is negative to positive infinity. Okay. Now let's talk quickly about our homework. We didn't finish all of 1/7, but we got through most of it. So 1/7, you should be able to do 1 through 7. We'll do the rational ones next time. If you haven't picked up your homework in a while, I have it up here. So let me find it real quick. Here's the right stack. So if you haven't picked up your homework, I'll put it over here. You can find your homework. And if you've got that 1/5 and 1/6, if you've got it done, I'll take it today. If you want to wait and turn it in on Thursday, you can turn it in on Thursday as well.